Good afternoon, class. You're looking at Module 4, College Algebra, that covers Chapter 7 and Chapter 8. Chapter 7, Systems of Linear and Nonlinear Equations. So, if the system of linear equations results in two parallel lines, the system is, well, it's an inconsistent system. The system has no solution. The graphs are parallel lines. They have the same slope, but different y-intercepts. Meaning M1 equals M2, but B1 is not equal to B2. And if you go through the process of solving the system, such as elimination method or substitution method, we end up with a contradiction such as 0 equals 7, 5 equals 2, things of that nature. So the system is inconsistent. If the system of linear equations results in two intersecting lines, the system is consistent with independent equations. The system has a single solution. At the point of intersection, the graphs are different. They have different slopes. Or you have to recognize that the two have different slopes. M1 is not equal to M2. They must intersect at a single point, and that is the solution. In the third case, and if the system of linear equation results in a single line, then the system is considered consistent with dependent equations. The system has an infinite number of solutions. The graphs are identical. They have the same slope and the same y-intercept. In other words, they're at top of each other. Here's an example of that where they have the same slope and the same y-intercept. So if we were to solve the system, such as the method of addition or substitution, we end up with an identity such as 0 equals 0 or 5 equals 5, and that represents an infinite number of solutions. The equations are dependent. We want to solve this system. We can easily see if we multiply the top by 5, the method of elimination will do that. If we keep the second one intact and multiply the first one by 5, we get, for example, minus 5x and 5x, they cancel each other. We notice that they cancel each other if we add them up. They cancel each other if we add them up, and we get 1. 0 equals 1. That's a contradiction. That's a false statement. Therefore, there is no solution. Which means if we solve for y, the two lines become parallel lines. We want to solve this system. If you want to get rid of the x, you can multiply the top by y and the bottom by 2. If you want to get rid of the y, you can multiply the top by 3 and the bottom by 7. Let's do that. So if you multiply the whole thing by 3, this becomes 6x minus 21y equals 9, and this becomes minus 35x. This becomes 21y, and this becomes 49. And notice, now we can cancel these two if we add them up. So these two add up to negative 29x. These two add up to 58. Divide both sides by negative 29. X becomes negative 2. And you can use one of the original variables for equations. For example, this one, 2 times x means 2 times negative 2 minus 7y equals 3. This is negative 4. Over to the other side becomes positive, with 3 becomes 7. Divide both sides by negative 7, and we get negative 1. Now, what's important is this. You must check your work. How? We use the first equation. Now you put this into the second equation. Must minus 5 times x, which is negative 2, plus 3 times y, which is negative 1. There's a question mark. Do they add up to 7? As you can see, this is 10 minus 3. It checks, and now you are positive that you have the correct answer. We want to solve the system here. We've learned the method of substitution, addition. We want to discuss the matrices as well. A matrix with m rows and n columns has dimensions m by n. So m rows, that means 1 and 2 rows. N columns, in this case also 2 columns. A square matrix has the same number of rows as columns, and we call them n by n. So this is a 2 by 2 square matrix. We can add them up if they have the same dimensions, and all you have to do, add the corresponding entries, 5 and negative 4, negative 6 and 6, 8 and 8, 9 and negative 3. So again, as an example, you would add these two to get to this number, and the rest will fall. That's as far as addition is concerned. The product A times B of M by N matrix A and an N by K matrix B is an M by K matrix that is the result. So you can only multiply two matrices if the columns of the first one is the same number as the rows of the second one. So look at this one. This has 2 rows times 3 columns. This one has 3 rows times 2 columns. And because these two are identical, you can do the math, and this will be the result, 2 by 2. And the way it works, you multiply this row by this column. So as an example, negative 3 times negative 6, 4 times 2, 2 times 3, and it gives you 32. So this 2. So again, minus 3 times minus 6 is positive 18. 4 times 2 is 8. 26. 2 times 3 is 6. They add up to 32. So I hope you see that. You can do the same thing. Multiply this one by this one, you get this one. Multiply this one by this one, you get this one. This one by this one, you get number 2. So this is the synopsis of matrices, short. So if you look at this one, you can just write the matrices as follows. Just write the coefficients, negative 1, positive 2, positive 5, negative 2, and then we put a line segment and we write the result, which is negative, and this is, by the way, multiply these two with the negative. So the augmented matrix is called. So minus 1, 5, 2, minus 10, and we have the last one, which is the result on the right side of the equation. And this is if we write it in this format, where the constant is on the other side. And by any chance, if any of them is missing, you have a 0 placeholder. Now, the idea of the matrices, okay, or Gaussian reduction is, if you want to go with that methodology, this must be changed to 1 by any method that is acceptable by row reduction. Whatever we can do to equations, we can do to rows. And for example, in this row, in order to change this negative 1, can multiply this one by -1. So we're going to multiply the whole row by -1. And the notation is that minus row 1 goes to row 1. So multiply this one by negative. This becomes +1, -2, +1. That's the first one. The next one is to make this entry 1, this entry 0. So the best course of action is to go column-wise. After you create one, everything underneath, and this happened to be only one more row, but let's say there are 10 rows. You make this one 0, this one, all the way to the end. That because you want to put it in the format which is called row echelon form. So to take this and change it to 0, if I multiply this row by 5 and subtract it from this one. So I'm going to write -5 row 1 plus row 2 is a new row 2. So we just write the first one unchanged. And the second one, if I multiply this one by 5 and subtract it from this one, that's the meaning of -5 row 1. That gives us 0 here. If I multiply this one by -5, +10 and -10, this happen to be 0 as well. If you multiply it by this one, you get -5 and 6. You get 1. And so what happens, if we get to this format, where one row is all zeros except the last entry, this indicates that there is an inconsistent system with no solutions. If they're all zeros, then it's a dependent system. And there could be a way that we get to the answer. I will show you in a moment. Now, with matrices, I did this by hand. You can also do it with a technology, for example, TI calculator. So how to enter matrix? There's a matrix editor by pressing second and x to the power of -1, and you put in the matrix, and then you go with row echelon form by writing REF in front of it. So take a look at what happens. So you're going to enter matrix A as a 2 by 3 matrix. I hope you realize this is 2 by 3. And then you put in all those -1, 5, 2, -10, all those entries. Then you say REF, row echelon form, and then you put the matrix, and it gives you that, and that's exactly what we got here. And it is different because it doesn't have to be done in the same order. What matters is that this is the same here, and it gives you the result. The idea is that this is your calculator. Over here, pressing second and x to the power of -1. So it's you press second and then inverse of x. And here's matrix A. If you enter matrix A, if you go to the right and edit, gives you a chance to put the matrix size. In this case, it was a 2 by 3. And just for the sake of argument, the first entry you can put -1. The second one is 2. The last one is -1. We move on to the second row, 5. Next one, -10. And the last one is 6. So this is the augmented matrix that we had. So you got to press enter. Now, if you go second mode and then second x inverse again, you can, if you enter that, it brings you the matrix. If you go second, X inverse, you go to the math, or EF, second, again, matrix A, and it will give you the answer that we have right here. Again, I will show you. So I was showing you how to input the information into a calculator, and it gives you what you see here. Again, just playing with the technology. Let's move on. We want to solve this again. You can do it by any method, substitution, elimination, or using matrices. So if you want to use the matrices, you write those numbers, 2 minus 7, 3 minus 5, 3, 7, and there's a line here, that's the augmented matrix. You want to make this one 1. There are different ways. One of them is you can multiply the top by 1/2. If you want to avoid fractions, if you multiply this one by 3 and add this row to it, this becomes 1. See, 3 times 2 and minus 5 is positive 1. So you can write this 3 times row 1 and row 2. So 3 times 2 is 6 and negative 5. So that entry becomes 1. If you multiply this one by 3, negative 21 and 3 is negative 18. And if you multiply this one by 3, you get 9 and 7, 16. So this is 1. You want to change this to 0. Therefore, first, let's write the very first row. We want to change this one to a 0. One way is to multiply the first row by 5 and add it to that. So if I multiply this one by 5, this becomes 5 and 5, negative 0. So this remains unchanged. This becomes 0, 5 times adding. And as you can see right here, so this is the row echelon form. You can, if you don't want to continue on that, this one can be changed to 1 by dividing by negative 87. However, just the meaning of this, I want you to see that this means 1 times x, means x minus 18y equals 16. That means 0 times x is gone, minus 87y equals 87. I'm going to write this for you because I want you to understand the meaning of it. But all I have to do, if I say 1 over minus 87 row 2 goes to row 2. If I do that, so 1 minus 18, 16. So now the new row will be 0. This is 1, and this is negative 1. And right away, this is the solution for y. So right away, this gives you y equals negative 1. And you can put that into the very first equation, this one, x minus 18 equals 16, and you find the y. That's the concept of a row echelon form. So take a look at what we do now. So we put the matrix, and instead, if you do REF, row echelon form, this is what we get. Again, doesn't have to look like yours. What is important is that this should give you the same answer, which means y equals minus 1. Okay. Now, if you do REF, reduced row echelon form, you don't have to do anything. It gives you actually the solution because this is an identity matrix of 2 by 2. They call it identity matrix of 2 by 2. Therefore, the answer is just looking at you. X is minus 2, y is minus 1. And as always, go ahead and check. Always check your work. Again, I just want you to be exposed to this methodology as well and the technology and how you use it. The system, I'm going to quickly show you two ways. I'm going to do it by hand. Also, I'm going to show you technology. So we have three equations. Let's give them a name, equations 1, 2, 3, so we can refer back and forth. And you decide which variable to get rid of. And as soon as you look at the first and second equation, you notice if you add them up, the y goes away. So right away, let's do that because it's very easy. So if I add equation 1 and equation 2, these two go away. This is 5x, this is 3z, and this is a positive 1. So I'm going to have this one. Because remember, we have three variables, x, y, z. We want to go to two variables and then 1. All right. Now, because I have not used equation number 3, I must use it. Do I use it with the first or the second one? Makes absolutely no difference, but you have to use this one. So which one do you use? The one that is easier. For example, since this is negative, this has -4, and remember, you want to get rid of the same variable, namely y. So why don't we multiply this one by 4, this one by 3? So this gives us 9x minus 12y plus 6c equals -45, 8x, 12y, 20z, 80. And as you can see, these two cancel each other. So 9 and 8, 17x plus 26c equals 35. And we put this, I'm going to call it equation 5. I'm going to put the equation 5 next to equation 4. And I have only variables x and z. And I'm going to get rid of one of them. So for example, if I want to solve for z, I can multiply this one by 17, this one by 5, but one of them negative. So if we multiply this one by 17, we're going to multiply this one by -5. So 17 gives us 85x plus 51z plus 17. I'm going to multiply this by -5, gives me -85x, -130z minus 175. As you can see, these two cancel each other when we want to add them up. These two, -79z, these two, -158. Divide by -79, you get the answer 2. Now you have to go back to either equation 4 or 5 to find the x. For example, this one is 5x plus 3 times 2 equals 1. And this is 6, of course. And this gives you -5. Divide by 5, x becomes 1. Now you must go to one of the original equations because it's got all three variables. For example, this one, 3 times x minus 1, minus 4y, which we don't have, plus 2 times z, which is 2, equals -15. And you can see that it'll give you the answer. This one is -3 plus 4, which is 1. You take it to the other side, becomes -1, and y becomes 4. So those are the three. Now, what is important is to check. Remember, we used equation 1. We must put it in equation 2 as well as equation 3 to make sure it works, and it does. The beauty of math is you can check your work and it doesn't take long. So again, if we were to use the technology, I hope you recognize the Augmented matrix is, let's just quickly write it. The augmented matrix, let's see what color we can use. The augmented matrix, let's go with 3, 2, 2, column wise. Minus 4, 4, 3, 2, 1, 5, minus 15, 16, 20. Let's move into technology. You put that in. So that's the first column, the second column, the third column. It can't show the fourth column. The fourth column is here. And now you can do row echelon form. And by the way, I call this B. I use the B matrix. You can use any of them. You have a few choices actually, quite a few. And notice it gives us fractions which sometimes make it difficult to recognize. We also do or EF, and I'm going to change this to a format. So this is or. We're going to change the answer to fraction. Okay. And if I do or EF in one shot, again, these are row echelon form. But if we go with reduced row echelon form, first of all, this is a 3 by 3 identity matrix. Identity matrix, all entries are zeros except the main diagonal. So that means X is minus 1, Y is 4, and Z is 2, and that's exactly what we got here. So or EF in one shot will give you the answer. These are the answers that we have. All right, we want to solve this. If we do this quickly by hand, and this has X, Y, Z, this doesn't have X, and this one doesn't have X. So if I multiply this one by 8, because I notice I can add these two if I multiply by 8 and they cancel each other. So when I multiply this one by 8 and I keep the third one intact just the way it is, I'm repeating the third equation. The second equation I multiplied by X, they cancel each other. They cancel each other, becomes 0. And this is minus 224. This is a false statement, therefore no solutions. There are no solutions. In this case, if I multiply, because let's say I want to get rid of the X, if I multiply by 3, I can get rid of that. The first row, I don't touch the second one, so minus 3X, minus 9Y, minus 6. And as you can see, this cancels out, this cancels out, this cancels out, we get 0 equals 0. This is a true statement. And that means infinitely many solutions. The way normally we represent it is that we represent it, for example, X, and then Y is a function of X. If you solve this for Y, you get negative 1/3 X plus 2/3. I'm going to leave it for you to do that. Solve for Y. That's what you get. And if you write it in this format, if you want to pick any pair, just pick X and you have the answer. For example, X is 5, replace it here, and that's 4. Minus 1/3 times 5 plus 2. If you did it with the technology, we put this in. REF, that gives us the zeros at the bottom, which indicates the same thing. We are dealing with a bunch of dependent equations, and there are infinitely many solutions. If I want to solve this, this is a system of nonlinear equations because we are dealing with quadratic formats. So substitution or elimination, whatever that works out, those are the best course of action. We don't have to do anything, just elimination, add up. These two cancel each other. These two add up to 4x squared. These two add up to 28. In other words, These two cancel each other. Divide by 4. X squared is 7 and x is plus minus square root of 7. So there are two answers for x. So if you use any of them, for example, this is easy. If you use x, whether you put positive square root of 7 or negative square root of 7, it doesn't matter when you square it becomes 7. So I'm going to put that in, and that results in 7 as y squared equals 16. I'm going to subtract the 7 from both sides, and y is plus minus 3. Please understand, 2 of that combination gives you a total of 4. And here's how you do the writing, everybody. Negative square root of 7 with negative 3 and negative with positive 3. Positive square root of 7 with negative 3, positive square root of 7 with positive 3. And you must check. The reason you must check, because we picked it from the second equation. So you check it with the first equation. So I'm going to check one of them. And by the way, it doesn't matter. You can even check with plus minus, which means you are checking the whole thing. So if I go with 3 times plus minus square root of 7 squared minus y, which is plus minus 3 squared. And I put a question mark because I'm looking for 12. I hope you realize this is 3 times 7, and this is minus 9, and 3 times 7, 21, minus 9. It checks, and we just came up. Notice we came up with the correct answer. Graph the system of inequalities. I hope you remember when we did the inequality, just one of them. Now we have 2 of them. So the best course of action is to assume you have one and finish the job, meaning the way we did that, we set this equal, the same thing here, and we make up an equation and we graph the line. So this one is 2x minus y equals 2. And this one is 3x plus 2y equals 6. Just if you look at this one, I want 2 pairs, the x-intercept and the y-intercept. If x is 0, y becomes negative 2. If y is 0, x becomes 1. In this case, if x is 0, y is 3. If y is 0, x is 2. So I am graphing these 2 lines by putting those 2 pairs. So that's the blue line, that's the red line. So first and foremost, we write the equation of a line. Those are the lines, not the inequalities. And if you go back to this, this has the equality, the blue one, so it's solid. This doesn't have the equality, so it's a dashed line. The very first thing, make the red line dashed line. Then you pick up a test point such as 0, 0. And you check with each one. So if I put 0, 0 here, 0 less than 2, that's a true statement. 2 times 0 minus 0, that's a true statement. So I'm looking at the red line. So 0, 0, that works. So I'm going to shade this region. That means this side. I'm just looking at the red line, which now it's a shaded, is a dashed green. And the second one, the blue one, if I put 0, 0, 0 is larger than or equal to 6, that's a false statement. So that means the blue one, this side is not the solution. It's the opposite side. Red and blue, that would be coming together because there are 1, 2, 3, 4 regions. They come together here. And so we have this and this. This is the solution. This region. Okay, this one is the solution. We want to graph this inequality. First, let's graph this equality of y equals x squared plus 1. Remember, y equals x squared is that. Take it up by 1 notch. So this is something you know. This is located at 0. And again, you pick up a test point. You pick some point inside. For example, if you plug in, if you pick 0, 2, 0, 3, 0, 4, 0, 6 that is clearly inside, and you put that into the original inequality. If x is 0, y is a 2, 2 is larger than 1 when you plug in. That is a true statement. So that works. If this point works, everything inside works, and you shade that. By the way, if you pick a number such as this one, 2, 0, you see that gives you a false statement here. So you can try it if you want. We'll look at a few word problems. Anybody wants to read this for us?
I can.
Please.
A chemistry lab assistant wants to prepare 10 liters of 48% acid solution. In stock, he has 80% and 40% acid solutions. How many liters of each in stock solution should he mix to prepare a 10-liter mixture?
Perfect. Anytime we have a word problem such as this one, we have to set up a table as follows. We have a solution, which is 80% solution, 40% solution. We want to mix them. This is a class of problem known as a mixture problem. So what happens is that when you mix two things, the volumes add up. The sum of their volumes is constant. It doesn't change. So let's plug in all the numbers that we see here. So 80% means 80% of 0.8, 40% means 0.4, and the mixture is 48% or 0.48. Now we have 10 liters of that. So we have the volume is 10 liters here. How much of each do we have? We don't know. How about X amount for the first one, Y amount for the second one? And first and foremost, this is an equation, X plus Y is 10. Secondly, when we say something is 80% acid or base or alcohol, only 80% is pure. So 0.8, the pure amount or the actual amount of acid is the product of this column and this column. So this gives you 0.8 times X. This gives you 0.4 times Y. This gives you 0.48 times 10 or 4.8. This is one equation, and this is another. X plus Y is 10. 0.8X plus 0.4Y equals 0.48 times 10 or 4.8. And this is a simple equation to solve, a system to solve. You solve for Y. You can use any methodology that you've learned. So substitution, Y is 10 minus X. And this is 0.8X. This one is 0.4 times 10 minus X. And the right side is 4.8. Now you are going to distribute. This gives us 4. This gives us minus 0.4X. So the main part is coming up with the table and these two equations. The rest are elementary algebra, very basic. So what happens next is that you can combine these two to 0.4x. You can subtract 4 and you get 0.8 on the right. And of course, if you divide by 0.4, you get x equals 2. And so if x equals 2, everybody, y must be 8. Therefore, you have 2 liters of what? 80% solution and 8 liters of 40% solution. Now, I'm going to leave it for you to check those answers with this. You must check with the second equation because we used the first equation. So all you have to do, just 0.8 times 2 plus 0.4 times 8, they must give us 4.8. We can check it out. We have a similar question, again, a mixed problem. How many liters of a solution that contains 15% chemicals must be mixed with 6 liters of solution containing 10% chemicals to make 10 liters of solution containing 12% chemicals? A mixture problem, you must always make up a table. So what are we mixing? We are mixing 15% and 10%. So that's 0.15, that's 0.1. To get a mixture, which is 12% or 0.12. So this is 0.15. And by the way, we have, if you want to go with the numbers, with 6 liters of 10%. 10% is 0.1. And the mixture will be 12%. And so how many liters of 15% we don't know about X amount, but we do know we are mixing them, so they mix up to X plus 6 as a total volume. And that's really the key behind the mixture problem. The total volumes, they must add up. And so this comes from the fact that you're mixing them up. Now, these two, if you multiply, you get 0.15x here. That's the pure amount of acid, because only 15% is pure or actual amount. 0.1, it's just pure amount of chemicals, doesn't have to be acid, whatever that chemical is, okay? Then 0.1 times 6, then 0.12 times x plus 6. And because you're mixing it, these two must add up to this. The first two add up to this. And basically you use now the multiplication here is 0.15x. This is 0.6. You use distribution, 0.12 times x, and then 0.12 times x, and then 0.12 times 6 is 0.72. Now we are going to move things around. I can move this way. And becomes negative 0.12x. And this one this way minus 0.6. And I get 0.03x on the left, 0.12 on the right. And x becomes 4. By the way, this, we can move the decimal at the bottom by 3, the same thing for the top, and 12 over 3 is 4 liters of 15% solution. Okay. A plane can travel 800 miles per hour with the wind and 720 miles per hour against the wind. Find the speed of the wind and the speed of the plane in still air. You want to set up an equation. There's really not much you have to do here. Just define your variables. I'm going to go with the initials. P represents the speed of the plane, W the speed of the wind. And so in this case, in the same direction, we have P plus W is 800 against each other. P minus W is 720. So it's ready to go. All you have to do, add up the left side. If you add up the left side, these two cancel each other. We get 2P. And the right side is 1520. Divide both sides by 2. P becomes 760 miles per hour. And if you put in the first one, for example, 760, and what number is 800? The wind is 40, which works with the second one as well. You really have to check with both equations. Could somebody read this?
I can. Admission tickets. Oh, admission tickets to the Braden River Little League All-Star Game costs $4.50 for children. A total of 225 tickets were sold, and a total of $500 was collected from ticket sales. How many adult tickets and how many children tickets were sold? Set up a system of equations and solve.
Excellent. Again, in essence, you have a mixture problem because the total size, the total number of children and adults are given. So you have to set up a table as follows. We have adult, children, total, and the ticket cost $4 for adults, $1.50 for children. Total of 225 tickets. So this is the number of tickets or number of people. The total is given to be 225. Then how much money did we collect? Total of, this is the total of money. This one, and this is the total amount of $500. So we put in what we have. Now, how many adults and how many children? You can go with X or Y, or I like to go with the initial A and C as an example. It's your choice, of course, which right away gives you this equation. A plus C is 225. A total number of tickets, 225. That means A plus C is 225. And then how much do we collect from the adults? 4 times A. How much do we collect from the children? $1.50 times C. And when we add them up, we get $500. So this last column is the second equation. A plus C is 225, 4A plus 1.5 C is 500. Now, by any method, okay. For example, if you multiply this one by -4, you get minus 4A minus 4C equals minus 900. And you just repeat the second one, you don't change anything. These two cancel each other. These two add up to negative 2.5C. Negative 2.5C. And they add up to negative 400. Divide by negative 2.5, and they cancel each other, the negative over negative. So, and by the way, this 2.5, you change it to 25, and the top is 4,000 now. I hope you know that. Two zeros corresponds to 100, divided by 25 is 4. 4 times 40 is 160. And if the total is 225 and C is 160, A must be 225 minus 160, which makes it 65. So this equation works, and I'm going to leave it for you to check with this one, meaning for the adults, 4 times 65, for the children, $1.50 times 160, they must add up to $500. You want to check that out. One leg of a right triangle is 4 centimeters less than the other leg. The area of a triangle is 70 square centimeters. Determine the length of each leg. Set up a system of equations and so on. So first and foremost, it looks something like this. The legs, we don't know. We can call them X and Y. We know the area is 1/2 base times the height. So the very first thing we write one leg is 4 centimeters less than the other one. So seems to me, again, if we go, and this may not be to scale, x is y minus 4, because it's 4 centimeters less, and a is 1/2 the base and the height. When we have a right triangle, the sides, the legs are base and height. So 1/2 x times y is 70. So this from the first part, and then this one from the area. First and foremost, we don't want to have a fraction, so we get rid of the 1/2 by multiplying by 2x, y becomes 140. Substitution is the best course of action. X is y minus 4, plug it in. And this becomes y squared minus 4y. Remove the 140, minus 140. You can do it by factoring. It's easy because you want two numbers. The product is negative 140 and the sum is negative 4. Those are negative 14 and positive 10. So the answer is either 14 or negative 10. As you know, sides can't be negative, so minus 10 is out. If y is 14 centimeters, x must be 14 minus 4, or 10 centimeters. And to check with that is very simple. Half of their product must be 70, right? Half of their product, half of 140 is 70. So you can quickly check to see for yourself that it does work. Here's the last question. Could somebody read that, please?
I can. The sum of three numbers is 105. The third is 11 less than 10 times the second. Twice the first is 7 more than 3 times the second. Find the numbers.
Perfect. First, let's define the numbers so it makes it easy to understand. The numbers are x, y, z. So the first number, let's say, is x, the second one is y, the third one is z. So you have, or a, b, c, whatever you want, but you have to define it. So the sum is 105. That means x and y and z, x plus y plus z is 105. So that's the first one. This one says the third one, z, the third one, z, is equal to 11 less than 10 times the second one. Well, 10 times the second one is 10y minus 11. Twice the first, 2x, is equal to 2 times x equals 7 more than 3 times the second. 7 plus 3y or 3y plus 7. So those are the three equations. As long as we have that, that's a translation, we should have no problem finishing it off. We notice this is a function of x and y. This is the function of x, y, z, and this is a function of z and y. So since z, the only one that has z is this one and this one, let's replace this z. Again, this is a different methodology. It goes pretty fast. If you want to use the technology, you have to bring everything to the left and put x, y, z, and then the number. But just the way it is, if I replace this z with 10y minus 11 into the first equation, so this is equation 1, 2, 3. In equation 1, I am putting this instead of that. I get x plus 11y and minus 11, I'm going to move it, make it positive 11 equals 160. So now I have two variables here, I have two variables here. Equation 1 and equation 3. Equation 1 changed it to this. This is a new equation 1, remember that. And equation 3, 2x equals 7 plus 3y, we're not changing that. All right, we can do the substitution. The best, instead of dividing by 2 and solving for x and making up fractions, let's multiply this one by 2. 2x plus 22y plus 232. And now this 2x, we're going to replace it with 7 plus 3y. So this 2x, we replace it with 7 plus 3y. And so what we have here is to add up to 25y. Subtract the 7, we get 225. Divide by 25 and y becomes 9. Z is 10 times y. 10 times 9, 90. Minus 11, 79. You can use this one, but I'd rather use the original ones because I have to check anyways. So why don't I use the first one? X and Y and Z, they must add up to 105. Let's plug in. Instead of Y, put 9. Instead of Z, put 79. And X, to solve it, becomes 17. So X plus 9 plus 79 is 105. Results in X being 17. So the first number is 17, the second one is 9. The last one is 79. I would try it one more time by checking it to be on the safe side because it doesn't take long, class.